Greetings, Earthlings. In today's installment of Wizardry, we're going to go over the triangle inequality. And specifically, I want to make this video slightly different from your typical triangle inequality video. And I want to show you guys, how do you practice this? We'll understand the concept fairly easily, I think. But I want to make sure you guys don't just kind of know it, but if you have a specific question dealing with this, or if you want to explore this, you know how to practice it. And I think very few people or videos tend to address that. So I want to emphasize how you practice this stuff. Now, on top of that, well, let's get started and we'll see. All right, so what is the triangle inequality? Let's introduce it through an example. So we have this triangle. Hopefully you guys can see. It's a little bright. Okay, so here's a triangle, and I have 3, 4, and 10. So you might think, okay, so what about it? So here's my question to you guys. Depending on the country you're at, so let's say you're in the US, I want you to go to a store, like let's say it's a Home Depot, or if you're in another country, doesn't matter, go to your country's equivalent of a big hardware or a store where you can basically, they can chop wood for you or stuff like that, or you can do it yourself. So, get out a measuring tape. And what I want you to do is try to build yourself a little bit, a tiny little table. So this could be 3 inches, 4 inches, 10 inches. It could be 3 feet. It could be whatever dimensions you want. But let's just say it's 3, 4, and 10. So you might think like I can just slap whatever numbers I want. So go ahead and try to build this, and come back to me, and let us know if you were successful or not. I think you will quickly figure out that if you make this 10, there's no way this can be 3 and 4. The way I like to think about it is, imagine you have a river. So let's say there's a river and it's flowing this way. And so this river is, let's say, only 10 feet wide. It could be 10 yards, meters, miles, whatever. Let's just say this is 10 feet. Now, imagine these two are like a drawbridge where boats go, right? So these are going to come up and down. So when they come all the way down and they're going to be flat, they have to span your entire 10. So if you think about the 3 and the 4, if they're flat, that's only going to get you 7. And if you go up, look at my hand. So if my hands move up, there's no way they're going to connect to form a triangle. So although I've drawn it to be a triangle, that doesn't mean it's an actual realistically possible triangle. So what this would actually look like, if I try to do it, would probably be something like this. Or if basically, so if you have these go down, they're not going to span your entire 10. So you might say, okay, well, what if they are, let's say, 3 and 7? How about that? Wouldn't that work? Well, no, because 3 and 7 only get you 10 when they're flat. The second they move up even a little bit, right? So let's draw that in here. So this would be 3, this would be 7. If we think about this drawbridge just coming up, it would be circular like that, and this would be circular this way. That's supposed to be a 7. So you'll notice, let's say they're like up here. Again, they're not gonna connect. It's too short. So if these two numbers, the 3 and the 7, if they add up to be exactly that third side, you don't have a triangle. You have a pancake. You have a flat triangle. So from here we get what's known as the triangle inequality, and all it is, it's common sense. So in this video, we're going to use one of the oldest hammers. That's right, hammer time again. And it's not going to be a mathematical hammer like in the previous video of triangles, polygons, stuff like that. We are going to use one of our oldest hammers, and that is common sense, which some people say is not so common, but anyway. So what is the triangle inequality in general? If you have a triangle with 3 sides, A, B, and C, those are their lengths. All it says is the sum of any two has to be greater than the third. So A plus B has to be greater than C, A plus C has to be greater than B, and B plus C has to be greater than A. From that drawbridge consideration. So for example, if A plus C is not greater than B, let's say it's too short or it's exactly equal to B, then these would be like this short, and then if you rotate them this way, they're not going to even reach. So that wouldn't be a real triangle. Same thing, like if A and B are too short, then they wouldn't span the C. Now they can be very long, that's fine. So for example, let's say here's your C. A and B can be huge. They can go all the way up into the sky because they're surely going to be able to reach, to span this distance of C. So that's what the triangle inequality is. The triangle inequality states the sum of any two sides in a triangle must be greater than the third side. All right, so I think hopefully that this is making sense. So now let's go to the second part of the video. And by the way, before we go into how to practice this and go through these examples, I would emphasize the theme in this video of the beginner mindset. I could have called this many other things like reviewing your fundamentals or you've never truly mastered anything. Any of those would be very similar. The idea is this, and this applies to myself as well. When I make videos for you guys, every now and then I will learn new things just by reviewing things that I thought I've already mastered. So triangles might not sound very exciting to you guys. You might think like, oh, I already know everything about it. The angles sum to 180 degrees. I know all the stuff. But you go back to even the basics. It could be going back to exponents, going back to geometry, multiplication. It doesn't even have to be mathematics. It could be, let's say you're into working out or fitness or video games or whatever. You're like, oh, I already mastered how to do a push-up, or I've mastered how to play with this character. When you go back, you might learn a few new things to take you to that next level. So never think you're too good for basics or fundamentals. And that's very much related to this, not exclusive to, but there's this like Eastern concept. I think in Taoism, don't quote me, but I'm always approaching things like you're a beginner, even if you're not a beginner. All right. So the practice is going to be split up into easy questions and hard questions. So most people learn the triangle inequality, which is this basic setup, and then they can do questions such as number one. So let me blow up number one for you guys. So you'll have a question like this, and you're asked, what is the range of acceptable values for x? So to do this, it's not going to be too hard because we can almost do it in our heads. And we're going to do this in a second, but most people are going to do this and feel like, okay, I can do this, so I've mastered the triangle inequality. And then they'll get questions like 2 through 4, and they'll be like, oh, I don't know what to do. So let's do number one first. For this, we don't have to do any fancy mathematics. We can just see, okay, if x is, let's say 5, that would be too short because these two wouldn't span the 12. So we know x has to be at least 7, so that in fact has to be more than 7. That way these two are longer than this third side. So we know that x has to be above 7. Just by looking at these three numbers. Now, can x be as large as we want? Can it be like 100? Well, if x is 100, these two are not going to be, their sum is not going to be greater than x. So there's a limit, right? X can't be even 20. So we look at these two, 5 plus 12 is 17. So x has to be below 17. So that's how you do this basic triangle inequality question. You can kind of eyeball it, just make sure you thought about the lower bound and the upper bound. And to do that, like I said, you might have to go all around the triangle. Don't just think about like these two are greater than that. It has to be these two are greater than that and these two are greater than that. Now, what you'll find in these problems is that one of those constraints won't really be necessary. So although it goes three ways, because we have the three being these two have to be greater than this, these two have to be greater than that, and these two have to be greater than that. If x is above 7, right? I mean, the 12 is already larger than 5, so there's no way that the sum of these two is going to fail to be larger than the 5. So one of those constraints will be inactive, it'll be bogus, like we already knew that. So don't freak out if you get 3 inequalities and only 2 of them are in effect, or kind of like the ones we should care about. That's your typical scenario here. All right, so that's number one. Let's see how to do, like to practice this and to achieve better mastery of this stuff. You want to look at questions where you're not given 2 or 3 numbers. So like going by 3 numbers, you might just be asked, is this a legitimate triangle or not? So that would be the 3-number question. And you say, okay, 17 is greater than 14, 19 is greater than 12, and 26 is greater than 5. Yes, all the way around it's good, so this is a legitimate triangle. Now the harder one is when you only have 0 or 1 numbers and the rest are variables. So let's do number 2. So x, 3x, minus 1, 5. Let me pause here for a second. So as we do these, just know I'm doing these just so you can get some good practice right now and see how this is done. But I want you to be able to practice this on your own. So how do you practice this? You literally take the same sort of setup and you play with the numbers. You put some different numbers. You make the 3x a 5x. You make the minus 1 a minus 2. You can make that x 4x plus 7. Just mess around with the numbers. But the idea is to cover all the possibilities. So you're not just doing problems of type number 1. All right. So let's see. So in this one, I'm not going to try to eyeball it because it's getting too complicated now. So we're going to set up 3 inequalities. We're going to do this the professional way. So this is the outline. We're going to say these two must be greater than this. So let's do that. I'm going to do this in our heads. In my head, I don't think this is too crazy, but if you have to break this out, in fact, let me break it out first and then we'll speed it up. So we'll do x plus, and I'm going to put parentheses only for readability. Has to be greater than 5. All right, so the reason I broke it out, of course, I can calculate this in my head, but then if I just wrote 4x minus 1, you might wonder, like, where did we get 4x? And this way you know we've covered these two sides. So our next one will be, let's say, these two. So it'll be 3x minus 1 plus 5. I don't have to put parentheses, but I'll do it anyway. Is greater than x. All right, and our third one is these two. 5 plus x is greater than 3x minus 1. I'm not going to put parentheses. This is already fairly easy to see. Okay, so here's the basic game plan. We have 3 inequalities, and we need to simplify these 3 inequalities. So I'm going to do this fairly quickly. So this is going to be 4x minus 1 is greater than 5. We're going to add 1 to both sides. So we're going to get 4x must be greater than 6 because that minus 1 was going to go to the right. So from here we're going to get something for x. I'll kind of leave it as that for now. For this one we'll have, I'm going to move the x to the left and get 2x and move the rest to the right. So this is going to be a positive 4. So it's going to be 2x has to be greater than negative 4 because this positive 4 moves to the right, so it becomes negative. This looks like it's going to be one of our bogus constraints because if x is a positive number, clearly it's going to be more than a negative number. So that might be one of our constraints we're going to throw out. This one. So let's move this x over. I'm moving the smaller x's to the larger x's. By the way, if you're having trouble with this, you might want to review the video in the series on solving inequalities. So I'm assuming you guys already know how to solve inequalities. I'm going to move this x here, so we're going to get a 2x on the right side. In other words, I'm treating these inequalities just like equations with equal signs, assuming I'm not multiplying or dividing by negative numbers. That would flip your inequality. If that made no sense, like I said, review the inequality video. This is going to be 2x, move that over, it'll be a 6. So 6, it has to be greater than 2x. All right, so just by glancing at it, I can tell this one's not going to be useful. So the ones we care about are these two. This is going to be, I usually use fractions, but here, okay, so x is greater than 3 over 2. That's from this one. And divide both sides by 2, x has to be below 3. So that would be our answer to number 2. Any value between 1.5 and 3 should make this a legitimate triangle. So you could, let's say, plug in 2, just spot check that it makes sense. All right, so that's number 2. Number 3 will have no numbers whatsoever. It'll have all expressions with variables. So let's do that one real quick. So the E and H just means easier and harder questions. Okay, so I'm just going to set it up from here. So let's add them up. So we're going to have 7x plus 1. The sum of these two must be greater than that. Has to be greater than 2x minus 1. Then we'll do those two. So 4x has to be greater than 5x, and then we're going to have 7x minus 1 has to be greater than 2x plus 1. All right, so just by glancing at this second one, you might notice something very suspicious. Unless, well, actually there is a way for this to be true, but we're assuming these are actual triangles, right? So we can't have negative lengths. So if I were to make x, let's say -1, then it is true that -4 is greater than -5, but in general, for positive values of x, 4 is never going to be larger than 5 multiplied by the same numbers on both sides. So, in fact, we're not even going to try to solve this. So, but you would have done this the same way. So, you could try to divide both sides by x, but then you just have 4. X could technically also be 0, so I'd rather you not try to do this mathematically. You can. Just kind of just look at it and think about it for a second. So you can just use your common sense. So this equation alone tells us this is not, we can't do this. Now, one way you could have seen this, right? So when you add these two, the +1s and the -1s cancel out. So just by glancing at it, you might have been able to tell that. So I would stop right here. So there's no value for x that is going to make this a legitimate physical triangle. All right, so that's number 3. We could have done all the work with the inequalities and just wasted our time. Now, believe it or not, I made up these numbers. So that was not my intention. So my intention was to actually have this happen for the last part, but oh well. So now let's look at the third one, and this one I'll make larger again. So we have our 2x, 4x, 7x, and in very much the same fashion here, I'm not even going to set up the inequalities. You can just tell that 2x plus 4x is 6x. So all of these are being scaled up. So think of like a baby triangle. The larger x's, the more you just scale up your triangle. So there's no way that 6 of something is going to be larger than 7 of something. Again, you can have negative numbers, but that won't create an actual triangle because lengths can't be negative. So just by looking at this, you can see that number 4 is impossible. So I would say that like the real heavy-duty thing that we did in this video is probably example number 2. So what I would really recommend you guys do, just make up some expressions like these, and just set up the 3 inequalities for each example and see what you get for your bounds. On occasion, when you make up numbers, you'll get what I got in example 3 unintentionally, like you think you've created a legitimate problem, but you get that it's actually impossible to get it to work. So I'd say, I don't know, some of the time you'll get legitimate triangles and some of the times you'll get bogus triangles. So have a go with that, and remember, beyond just the triangle inequality, all the stuff we do on this channel or stuff you come across in life, anything at all, don't feel that you're like way too advanced and it's below you and your ego to go and review stuff. You might learn, in fact, when you get more advanced and there's like this cliche expression that you'll see things with new eyes. So you might have, like even let's say Fibonacci numbers. I did a video a while back on the golden ratio and Fibonacci numbers. I've known that for a long time, but when I was doing the video, I learned a lot of stuff that actually I was always curious about, but I wasn't ready to appreciate it as a beginner. So anyway, that's my little kind of 2 cents on having the beginner mindset. I will see you guys in the next few videos where we go into kind of more and more advanced, cool geometry stuff. See you guys.